variables. It's fine. But there's nothing here. When there are no limits of integration, these are called indefinite integrals. Indefinite integrals. So what is the answer to this? Find a function whose derivative is 2x. What's that? X squared plus what? C. Got to put a plus C in there. Why do you have to put a plus C in there?
Plus a constant.
Because
there could be
any constant, right? Any constant could be there. We've talked about this many times. How many integrals does a given function have? An infinite number, right? What about this one? 4x. Who has that one? 2x squared plus c. You drop the 2 to the front, it needs to become 4, and there's still plus c. What about this one? What's different about this one? What's different about this? What's new here, or slightly different than the other ones? Yeah, x cubed plus x squared plus what? Plus c. Yeah. How do you guys feel about these so far? These are relatively straightforward because they are all power functions, or the sums of power functions. A power function is ax to the n. What's the indefinite integral of ax to the n? We've talked about this. X to the
n minus 1.
And we're integrating, so it goes plus 1, right? But then what goes out front? Not plus a, plus 1. What goes out front?
1 over n times a.
1 over what?
N times a.
No, you're not differentiating, you're integrating. You're going the opposite direction. We've written this out before. This is not new.
1 over n plus.
It's n plus 1, but then what goes out front here on top? Not a does. A, like this. When you take the derivative of this, it turns into that inside the integral. So all the ones we just did are all just power integrations with the power rule. Okay, all those a values are still there, right? That 3 is there, that 5 is there, that 2 is there, that 8 is there, right? And that 1 is there, it's in front of the x. We good with this? Okay, so what's the difference now? This is now a definite integral because it has limits of what? Limits of? What are the two limits of integration on this one?
0.
So the first thing you have to do is write the indefinite integral. Chris, can you tell me what the indefinite integral of this is? Limits of integration, 0 to 5. That bar means you're integrating it from 0 to 5. Now, can you simplify that a little bit first? What's 3 over 3? So this is really just x cubed plus x squared plus c from what?
0.
And from 0 to 5 means you plug in 5, and then you subtract what you get when you plug in 0. So let's plug in 5. What do you get? 5 cubed plus 5 squared plus c, right? Minus what? 0 cubed plus 0 squared plus c. What cancels when you do the subtraction? The c's cancel. And what are you left with? 5 cubed plus? So that's 125 plus 25 is what? 150. Are the c's always going to cancel out? Yeah. The c's are always going to cancel out. So you're going to have a tendency, everybody, when you do definite integrals, is it going to be 100% required to plug in the c eventually? No, you can drop that because you're going to add c and then subtract it a whole hundreds of times. For now, it's very important that you do plug it in because it will be important later. You need to remember that when you integrate, there is a plus c there. How do you feel about what's on the board right now? How do you feel about that? Is that pretty good? We good? Do you think you can do another one? Try this one by yourself. Try to get a final answer for this one right here. Try to get a final answer for this one. To find the indefinite integral. Noah, what is the indefinite integral for this one? 2 over 4 x to the what?
1/2 x, x
the fourth plus
1/2 x squared.
Yep.
And then you do bar 2, 4.
Yeah, from 2 to 4, right? So you can simplify that a little bit. It's going to be 1/2 x to the 4th plus 1/2 what? And I want to show you one thing you are totally allowed to do. What can you factor out at this point? You could factor out the 1/2. That's what I would do, like this. So I would do this x to the 4th plus x squared from 2 to 4. You can definitely do that at the end. So what's that going to be? 1/2 times what? Well, what's 4 to the 4th? You used your calculator. What's 4 to the 4th? That's 64 times 64. What's that?
328.
64 times 64 is 328? I think it's 256. What's 4 to the 4th? It's 16 squared is 256. That's much better. 256 minus 2 squared is? I'm plugging in 2 into this. Oh, excuse me. We have to do two things. 256 plus 16, right? Minus, what's 2 to the 4th? 16 plus 4. Does everybody see where those came from? Are you good with where those came from? Yeah, we're nodding.
I just did it differently.
That's fine, but do you understand where those numbers came from?
Yeah.
So what do you do here? You have 1/2, and then what do you have? What's 256 plus 16? 2 what? 66 plus 6 is 272 minus 20, right? So that's 1/2 of what? 252. So what's that? 126. Yay.
So I understand the process.
Yes.
I just don't know what we're answering.
We are answering the area under the curve from 2 to 4 of that function. We just figured out the area under that curve, 2x cubed plus x,
Right, so we
from 2 to 4.
But why did we have to do that integer thing?
See, the lower function is the axes. So what is the lower function? I'm being overly complete right now. Yeah, it'd be minus what? 0 dx. Because we're at the function y equals 0, right? Could you replace that lower function with any other lower function? Absolutely, as long as it stays below the other function from 0 to 4. Do all functions strictly stay below other functions? No, like you could have a function like this, right? And then could you have a second function that goes like this? Does it change which one's on top and which one's below? Well, yes, it does. That's what I'm trying to say here. On this function right here, like for here, what function's on top? Red. But over here, what function's on top? Blue. So when you're finding, if I ask you to area between things, you have to make sure that one function is always on top and one function is always on the bottom. And if they switch, how many integrals do you have to write? 2 integrals. Or you use that what's that cool function on your calculator? The 2 bars, what's that called? Absolute value. Absolute value. So let's start some of this together. Let's start. And then what power do you think it has to go to? Well, it goes up 1, right? So it's x plus 1 to the what power? 3/2. But what do we put out front to get rid of that 3/2? What do you multiply 3/2 by to get 1? Come on. This is something you would learn in Algebra 1. What do you multiply 3/2 by to get 1? 2/3. Thank you. Right. 2/3. When you drop 3/2 to the front, what is 3/2 times 2/3? 1. So look, this equals 5? Yeah, okay. Ah, there you go. 5 over 5. Oh, no, well, you get 6 over 6. It's like, it's okay. Did you guys see the SNL sketch on Saturday? Tiny bit. Let's say I asked you this. X times the square root of x plus 1. I only changed it by adding in 1x. That's it, right? It completely changes how you integrate that. That is annoying to integrate. Like you need BC calculus to integrate that. So you can change small little things and all of a sudden it goes in terms of difficulty. Real hard. For example, here's another one for you. E to the x. Here's a function. E to the x. You've seen that function before, right? How about this function right here? Y equals 2x. Do they intersect? Yeah, they definitely intersect. They intersect right here. Here's a fun question. Where? Where do they intersect? If you use your calculator, can you do that real quickly? Yeah. Theoretically, like, oh, I could do that by hand. It's only 5 symbols, right? 2x equals ex, right? It's actually really hard to solve that by hand. Really hard because there's an x in the exponent and not in the exponent. Makes it much harder. So if you change little tiny things, all of a sudden you're like, okay. So let's take a look at those homework questions. Break it into 4 fractions, and what do you get? The integral of 2x to the, I wish I could write it properly. 2x to the 4th over 2x squared dx plus the integral of 6x cubed over 2x squared dx minus the integral of 5x squared over 2x squared dx plus what? 8 over 2x squared dx. So what do you do before you integrate? What should you do to each of these? Before you simplify, right? So what's this one? What does that simplify to? That's just x squared dx plus the integral of what? 3x, right? Minus the integral of what? 5 over 2 dx plus, what's this one? Oh, thank you, dx. And then what's this one? Plus the integral of what? So it's 8 over 2, so what's that become? 4 over x squared dx. Now, before you integrate, you can do something here. What are you allowed to factor out to the front of each of these integrals? It was one of the rules we learned yesterday. What can you factor out to the front? What can you factor out of things? What are these called? Coefficients, right? The leading coefficients. So let's pull them out. So what do you end up with? The integral of x squared dx. What do you plug out here? Pull out? 3 times the integral of x dx minus what? 5 over 2. It's 5 over 2. Yeah, it's just 5 over 2 dx, right? So you can call that, put a 1 there if it makes you feel better, plus 4 times the integral of x to the what power? Negative what? Negative 2 dx. So let's keep on integrating here. Let's keep on integrating. I'm going to just ignore this for now. What does this become? Let's integrate now. What's the integral of x squared?
1 over 2.
1 over, not 2, 1 over 3x cubed plus 3 times, what's the integral of x? What's the integral of x?
X is over 2. X. Sorry, I'm blank here.
It's okay. What's the integral of x?
It's just 3 over 2 x
Not-
squared.
so-
1/2 x squared.
1/2 x squared, right?
Oh, I'll just put
Correct.
it on top.
And what's the integral of just dx?
Just dx.
What's the integral of 1? What's the integral of 1?
X.
Yep, so this is just negative 5 over 2 times x. And then what's this one? 4 times. What's the antiderivative of x to the negative 2? The power goes up 1. So what's the power going to be? X to the what?
Negative 1.
But then what do you have to plug out front? Why do you have to put a negative 1 there?
Because it did negative 2.
Yeah, you need to make it positive, right? When the negative 1 drops to the front, is there a negative sign out front here? Is there a negative sign out front?
No.
No, so you need to make sure that you get rid of that negative. Yes, Chris?
Would it be 1 over negative 1? Or just negative 1?
Just negative 1.
Okay.
So what is this final answer? X, 1/3 x cubed plus 3 over 2 x squared minus 5 over 2x plus what? Or minus what? Minus what?
This is negative 4x.
Negative 4x to the
Negative 1.
plus c. So we think this is the final answer. How would you check this answer? How would you check to see if this is the right answer? What would you do? How do you check to see if this is the right answer? We take the derivative. So let's take the derivative. Let's check this. Let's check it. I'll change colors here to green. What's the derivative of the first term? Fitch, what's the derivative up here? Take a look up here. What's the derivative of that first term?
Sorry.
It's okay. What's so negative 1, and then it's x to the, and then the c goes away, right?
Yeah.
So then that right there should theoretically equal this thing right here. Can we turn it into that? We can, but we have to undo each of the steps here. We did the factoring. Does this match right here? Oh, it does. Okay, and then that would match this, and then that would match this. So does it match? Yes. So you check. I'm not going to go through each step right now, but how do you check your integrations
Find the derivative.
and see if it matches? This one's a little bit annoying to do. I apologize. It's just how it is though sometimes.